Before the satellites came, the night sky was a much quieter place. There were no thin white lines of Starlink drifting over dark neighborhoods, no weather satellites turning silently above the clouds, no GPS constellations whispering invisible signals back to Earth, no space stations catching the last light of the sun and sliding like slow sparks across the evening. For most of human history, when someone looked up at night, they were looking into something almost untouched by our machines. There was the moon, pale and familiar. There were the planets, wandering slowly among the stars. There were meteors, brief and bright, burning themselves away in the upper air. And beyond them, there was the deep, ancient background of the universe, a darkness filled with stars so old that their light had begun its journey long before any human city had ever existed. The sky was not empty, but it was natural, or at least that is what we like to believe. Tonight, we are going to travel back to a strange and quiet moment in history, a moment just before the space age began, before humanity placed its first artificial moon in orbit, before Earth became surrounded by metal, antennas, solar panels, and debris, before our planet developed the shimmering mechanical halo it has today. We are going back to the 1950s, a time when the world was changing quickly, but the heavens above us were still supposed to be clean. On mountaintops, astronomers opened the domes of great observatories and pointed their telescopes into the cold dark. They did not yet have digital sensors. They did not yet have the modern instruments we use today to map the sky in extraordinary detail. Instead, they captured the universe on large glass photographic plates. Night after night, starlight fell through the telescope and touched those fragile surfaces. Each plate became a frozen piece of sky. A silent record, a memory made of silver, glass, and time. Most of what appeared on those plates made sense. Stars, galaxies, nebulae, asteroids, tiny points of light that belonged exactly where the universe said they should belong. But decades later, when some of those old images were compared with modern surveys, researchers began noticing something strange. Some lights were there, and then they were not. Small points appeared in old star maps, only to vanish from later records. Some could be explained. Some were likely flaws in the photographic plates. Some may have been dust, scratches, chemical marks, or ordinary stars behaving in unusual ways. But a few of them were harder to dismiss. They were not ancient legends. They were not campfire stories. They were not frightened witnesses staring at shapes in a stormy sky. They were marks in astronomical data, recorded by instruments, preserved across decades, waiting quietly in archives until someone looked again. And that is where this mystery begins. Because some of these little lights seemed to behave in a way that felt strangely familiar to modern eyes. They looked, at least for a moment, like brief reflections. Like sunlight glinting off something small and metallic. Something high above Earth, something in the dark. Today, if we see a sudden flash in the night sky, there are many ordinary explanations. A tumbling satellite, a piece of space debris, a high-altitude aircraft, a reflection from a solar panel moving through sunlight while the ground below has already entered night. But there is a problem. Some of the most curious images were taken before humanity had launched its first satellite. Before Sputnik, before the official beginning of the space age, before there should have been anything artificial in orbit to catch the sun. So what were those lights? Were they only old scars in the glass? Were they natural objects we still do not fully understand? Were they errors born from chemistry, radiation, dust, or time? Or did the pre-satellite sky contain something that we have never properly explained? We should be careful here. A mystery is not the same as proof. An unexplained light is not automatically a visitor from another world. The universe is full of strange things, and human instruments are never perfect. Old photographs can mislead us. Data can hide mistakes. Patterns can appear where none were intended. And yet, the question remains quietly open. What if, before we filled Earth's orbit with our own machines, something else had already crossed above us? What if the old sky, the quieter sky, preserved a few faint traces of something moving through the darkness? Not enough to give us certainty, not enough to end the argument, but enough to make us pause, enough to make us look again. Tonight, we will not chase wild rumors. We will not leap quickly to answers. We will move slowly, carefully, through old stories, old observatories, old photographs, and the deep shadow of Earth itself. We will begin with the sky as our ancestors knew it. Then we will travel to a German city in the year 1561, where frightened witnesses described strange shapes above the morning sun. From there, we will leave legend behind and climb to a quiet mountain in California, where glass plates once captured the universe one night at a time. And finally, we will come to the strange lights themselves, tiny points in old star maps, appearing, vanishing, waiting, because sometimes the deepest mysteries do not arrive with thunder. Sometimes they are no larger than a dot of light on a forgotten plate of glass. And sometimes the quietest sky may be the one that remembers the most. To understand why these old lights feel so strange, we first have to remember what the sky used to be, not in ancient times, not thousands of years ago, but only a single lifetime ago. There was a time when the space above Earth did not belong to machines. Today, we live beneath a sky full of movement. Most of it is invisible to us. Satellites pass over our heads every hour. Some carry television signals. Some guide ships across oceans. Some help airplanes find their way through clouds. Some watch the weather form over distant seas. Some listen, some photograph. Some simply drift, no longer useful, quiet fragments of human ambition circling the planet. Even when we do not see them, they are there. A thin mechanical shell around the world. A second, artificial sky. But before the autumn of 1957, none of that officially existed. There were no human-made objects in orbit. There were rockets, yes. There were aircraft. There were balloons. There were secret military projects, radar stations, experimental machines, and the growing tension of the Cold War. But Earth itself was not yet surrounded by the metal fingerprints of civilization. The upper atmosphere was still mostly untouched. The region above it, where satellites now travel in silent streams, was still imagined more than occupied. For anyone looking up from the ground, the night sky still belonged to the old universe. And that is difficult for us to feel now. Because we have become used to a crowded sky, a person standing in a dark field today may see a slow light crossing from west to east and immediately know what it probably is: a satellite, a piece of orbital hardware catching sunlight, a human object, far above the clouds, moving with patient precision across the stars. It is no longer surprising. But imagine standing in the year 1950. Imagine walking outside after midnight, far from the city lights, when the air is cold and still. The houses behind you are dark. The roads are empty. The world is quiet in the way it only becomes when most people are asleep. You look up. Above you, the stars do not move quickly. They wheel slowly with the rotation of Earth, too gradually for the eye to notice moment by moment. The moon, if it is present, glows with its ancient calm. A planet may shine low near the horizon. A meteor might flash and vanish in a heartbeat. But there is no expectation that a steady artificial point will glide overhead. No ordinary person has yet watched a satellite cross the sky. No child has yet been told to look for a space station. No astronomer has yet had to calculate how many human objects might contaminate a long exposure of the heavens. The sky is still, in one important way, innocent. And it is this innocence that gives the mystery its weight. Because after the space age began, strange lights became harder to interpret. Too many new explanations entered the sky at once. A sudden flash might be a satellite flare. A moving dot might be a rocket body. A strange streak might be debris, a classified payload, a re-entry, a piece of insulation, a tumbling panel, or one of thousands of known objects reflecting sunlight above the dark side of Earth. Modern orbit is noisy. The old orbit was not. So when researchers look back at images from before Sputnik, they are looking into a cleaner record. Not a perfect record. Never perfect. Old photographic plates can be flawed. Dust can settle on glass. Chemical emulsions can age in strange ways. Cosmic rays can leave marks. Human hands can introduce scratches, fingerprints, or tiny imperfections that later masquerade as stars. But still, the sky itself was simpler, and simplicity matters. If a sudden point of light appears in a modern photograph, the list of possible explanations is long. If a similar point appears in a photograph from 1950, that list becomes shorter. Not empty, but shorter. There is a kind of silence in that difference. A silence that invites us to listen more carefully. The world of 1950 was already filled with human tension. The Second World War had ended only a few years earlier. The atomic age had begun. Nations were building weapons with a power once reserved for myth. Radar screens watched the air. Laboratories dreamed of rockets. Governments looked upward not only with wonder, but with strategy and fear. Humanity was changing quickly. But above all of that, the stars still seemed ancient and distant. The idea that Earth itself might soon have objects circling it was no longer pure fantasy, but it was not yet an everyday reality. Space was still the next frontier, not the environment of routine technology. And in that brief, strange window, just before the first satellite rose, the sky was being photographed. Quietly, patiently, night after night. Astronomers did not know that future generations would one day search those images for signs of anything unusual near Earth. They were not hunting for alien machines. They were mapping stars, cataloging the heavens, building a record of the universe as it appeared through the eyes of their time. A telescope opened. A plate was placed. The shutter waited. And then, for minutes at a time, the sky wrote itself into glass. The light of stars fell down from unimaginable distances. Some of it had crossed space for centuries, some for thousands of years, some for millions. And beside those old lights, perhaps, a few brief glints appeared. Small, temporary. Almost nothing. The kind of mark a tired researcher might overlook. The kind of mark that could be dismissed as dust. The kind of mark that only becomes strange when you ask when it was made. Before satellites. Before orbit became crowded. Before the sky learned the language of machines. That is why the old sky matters. Not because it gives us answers, but because it removes some of our easiest ones. It takes away the familiar explanation that something was simply one of ours. And once that explanation is gone, we are left standing beneath a darker, quieter, more mysterious heaven. A heaven where every sudden light must be handled with care. Because in the years before machines crossed the night, the appearance of something that looked like a machine becomes one of the strangest questions the sky can ask. And yet, even long before telescopes and photographic plates, people had been asking questions like this. They had looked up and seen things they could not name. They had watched lights move, burn, split, fall, and disappear. They had written them down as omens, battles, warnings, miracles, and signs. To follow this mystery further, we have to go back much farther than 1950. Back before satellites, before rockets, before cameras. before science had given the sky most of its modern names. Back to a time when a strange light overhead could feel like a message from heaven itself. Long before machines crossed the sky, long before the first telescope gathered starlight, long before humanity understood what comets were or why the moon changed shape, people were already watching the heavens with wonder and fear. The sky was the first great mystery. It was always above us, always present, always changing, but never close enough to touch. To ancient eyes, the heavens were not empty space. They were a living ceiling of signs, a dark ocean where gods, spirits, ancestors, and warnings could appear without invitation. The stars were patterns, the moon was a clock, the sun was a power beyond all human power, and anything unusual in the sky felt important, because the sky itself felt important. A storm was not simply weather, it was anger. A drought was not only a failed season, it was punishment. A comet was not just ice and dust falling inward from the outer solar system. It was a blade of light, a bad omen, a torch in the heavens, a message that something on Earth was about to change. And in a way, it is easy to understand why people felt this. Imagine living in a world without electric lights. At night, darkness was real, not the soft darkness of a modern bedroom, where the glow of a phone or a city skyline slips through the window, but deep darkness, rural darkness, ancient darkness, a darkness so complete that the Milky Way did not appear as a faint blur, but as a river of silver smoke crossing the entire sky. The stars would have been brighter than most of us have ever seen them. The moon would have ruled the night. And any strange movement overhead would have felt enormous. A meteor, streaking green across the upper air, could look like a spirit falling. A bright planet near the horizon, trembling through thick atmosphere, could seem like a fire suspended above the world. An aurora, rippling red across northern skies, could look like armies fighting in heaven. A halo around the sun, caused by ice crystals high in the air, could be interpreted as a crown, a warning, or a sign of divine judgment. People were not foolish for seeing meaning in these things. They were human. They were doing what humans have always done when faced with the unknown. They were trying to make the strange feel understandable. They were trying to turn fear into story. And many stories began this way. A light appears in the sky. No one knows what it is. Someone gives it meaning. Someone else remembers the meaning. Years pass. The event becomes a warning, a legend, a miracle, a battlefield in the clouds. Then centuries later, we look back with modern eyes and try to separate what was seen from what was believed. This is not always easy, because the sky truly does create illusions. The atmosphere bends light, it scatters color, it magnifies objects near the horizon. It creates mirages, halos, pillars, rings, arcs, and mock suns. It turns ordinary things into extraordinary visions, when conditions are just right. A sundog can make it look as though there are 3 suns in the sky. Ball lightning, if the rare reports are accurate, can drift like a glowing orb close to the ground. Noctilucent clouds can shine after sunset, like ghostly blue waves high above Earth. Meteors can explode with enough force to shake windows and cast shadows, and to someone without modern science, any one of these could seem impossible. So when we read old accounts of strange lights, we have to be careful. Careful not to mock them, but also careful not to believe them too quickly. Because history is full of honest witnesses who saw something real, then explained it through the only language their time gave them. A comet became a prophecy. An eclipse became a dragon. A meteor shower became arrows from heaven. A solar halo became a sign of war. The event may have been real, the interpretation may have been wrong. And this is where the mystery of unusual lights becomes delicate. There is a difference between saying, people saw something strange, and saying, we know what that strange thing was. The first statement may be reasonable. The second requires evidence. This matters because many modern stories about unidentified objects reach backward into history. They search old chronicles, religious texts, paintings, carvings, and newspapers for anything that sounds like a flying craft, a glowing sphere, a dark disk, a cigar-shaped object, a battle in the sky, a wheel of fire, a star that moved against the stars. And sometimes, the descriptions do sound strangely familiar, almost too familiar. A round object hovering above a city, a long dark shape crossing the sun, lights that split apart, move in formation, or seem to fight with one another. From a distance of centuries, it is tempting to look at these accounts and say, perhaps they saw what we now call unidentified aerial phenomena. Perhaps they saw machines. Perhaps they saw visitors. But that is a dangerous jump. A beautiful jump, perhaps. A thrilling one. But still a jump. Because the past does not give up its secrets easily. A medieval writer may describe a shield of fire in the sky, but we do not know exactly what he saw. We do not know the weather. We do not know the position of the sun. We do not know whether the report was copied from another source, exaggerated, misunderstood, or shaped by religious expectation. We do not know what was in the mind of the witness, and we cannot go back and ask. All we have are fragments, words, drawings, translations, memories preserved by people who often believed the heavens were speaking directly to Earth. Still, there is something haunting about these old records. Not because they prove anything, they do not, but because they remind us that the sky has always been capable of unsettling us. Every generation has looked upward and found something it could not explain. Every age has believed it stood close to the edge of understanding, only to discover that the universe was wider, stranger, and less obedient than expected. And perhaps that is why these stories stay with us. They are not only about lights. They are about our relationship with the unknown. They show us a human being standing under the night, just as we do now, staring at something above the world and feeling the old question rise inside the mind. What is that? Where did it come from? Is it natural? Is it a sign? Is it watching us? Most of the time, the answer is ordinary. A planet, a cloud, a meteor, an illusion of light, but not always right away. Sometimes the answer comes centuries later. Sometimes it never comes at all. And among all the old stories of strange things in the sky, one of the most famous comes from a spring morning in Germany, in the year 1561, a city waking beneath the dawn, a crowd looking toward the sun, and above them, according to the record, a sky filled with spheres, rods, crescents, smoke, fire, and a long black shape like a spear. It is a story that has echoed for more than 400 years. Not because it proves that something non-human flew over Nuremberg, but because it shows how powerful an unexplained sky can be, and how difficult it is, even now, to look back at an old mystery and know exactly where wonder ends and evidence begins. On the morning of April 14th, 1561, the city of Nuremberg woke beneath a sky that people would remember for centuries. It was early, very early, somewhere between 4 and 5 in the morning, when the world is neither fully night nor fully day. The hour when streets are still quiet, when rooftops are dark, when the first pale light gathers slowly behind the edges of buildings, and the human mind is still soft with sleep. Above the city, the sun was beginning to rise. And then, according to the account that survived, the sky changed. People looked upward and saw strange forms near the sun. Spheres, rods, crescents, crosses, shapes that seemed to move against one another, as though some kind of battle were unfolding in the morning light. The report described objects flying back and forth. It spoke of globes and long forms, of things that appeared to fight for more than an hour. Some seemed to fall from the sky toward the earth, burning as they descended. Smoke was said to rise where they vanished. And after the spectacle, there appeared something dark, long and thick, a black shape like a spear stretched across the sky. To the people of the time, this was not a scientific puzzle. It was a sign, a warning, a message from God. The world of 1561 was a world where the heavens were still understood as a place of divine meaning. If something appeared near the sun, if strange lights filled the dawn, if shapes seemed to battle above a city, it was natural for people to search for moral meaning. Perhaps it was a call to repent. Perhaps it was a warning of punishment. Perhaps it was heaven, reminding earth that human beings were small. And in that sense, the story tells us as much about people as it does about the sky. Because we do not only see with our eyes, we see with our time. A person in the 16th century saw signs. A person in the 21st century might see aircraft, missiles, drones, or unidentified aerial phenomena. The same description passes through different centuries and comes out wearing different clothes. That is what makes the Nuremberg event so fascinating and so dangerous, because to a modern reader, the old illustration can feel strangely familiar. Round objects in the sky, long cigar-like shapes, dark forms, smoke, fire, something like a conflict above a city. For anyone who has spent time reading modern reports of unusual aerial phenomena, the language almost seems to echo forward in time. It is tempting to imagine metal objects over Nuremberg, a fleet, a crash, a visitation. A sign that whatever people see today has been seen before. But this is where we have to slow down, because a story that feels modern is not the same as a story that has been proven. The Nuremberg account is powerful, but it is also fragile. We do not have a photograph. We do not have radar. We do not have multiple independent instrument records from different locations. We do not have recovered material from the alleged fallen objects. We do not have atmospheric measurements from that morning. We do not have a way to replay the sky. What we have is an old report, an old image, and the knowledge that people saw, or believed they saw, something that deeply unsettled them. That is not nothing, but it is not enough. There are possible natural explanations. Some have suggested sundogs, bright patches of light caused by ice crystals in the atmosphere, sometimes appearing on either side of the sun. Others have proposed solar halos, parhelia, unusual cloud formations, optical effects near sunrise, or even a combination of atmospheric phenomena interpreted through fear and religious expectation. Could such explanations account for every detail? Maybe. Maybe not. The problem is that we do not have the data needed to decide. And without data, every interpretation floats. The skeptic can say, it was an optical illusion. The believer can say, it was a battle of unknown craft. The historian can say it was a religiously framed sky event. The scientist can say there is not enough evidence to know. All of them can speak. None of them can close the case. This is why ancient sky stories are so difficult. They are emotionally rich, but scientifically thin. They draw us in because they feel like windows into something enormous. But when we step closer, the glass is fogged. The image is old. The words have passed through centuries of translation, interpretation, and imagination. And yet, we should not dismiss them too easily, because behind every old account, there may have been a real event. Something did happen. Perhaps not exactly as described. Perhaps not in the way later readers imagine. But something in the sky made enough of an impression that people recorded it, printed it, preserved it, and passed it forward. A strange dawn, a frightened city, a sky that seemed, for one morning, alive with forms. That is worth remembering, not because it gives us proof of visitors, but because it shows us the beginning of a pattern. When the sky behaves in a way people cannot explain, human beings reach for the largest explanation their culture allows. In the 16th century, that explanation was heaven. In the modern age, it may be extraterrestrial technology, but the deeper impulse is the same. We see something above us. We feel small. We feel watched by the unknown, and we ask whether the universe has turned its attention toward us. Nuremberg teaches us another lesson as well. It teaches us why evidence matters. A witness can begin a mystery. A drawing can preserve its shape. A story can carry it across hundreds of years. But none of these can fully answer the question. To move from wonder to knowledge, we need more than memory. We need measurement. We need repeated observations. We need records that do not depend only on fear, faith, or imagination. We need the sky to leave behind a trace that can be examined long after the witnesses are gone. And this is where our journey begins to change. The old stories have brought us to the edge of the question, but they cannot take us further. To go further, we must leave the crowded streets of Nuremberg. We must leave the dawn of 1561. We must leave behind the age of omens and divine warnings. And we must travel forward into a century of glass plates, mountain observatories, careful measurements, and machines designed not to interpret the sky, but simply to record it. Because if something truly strange appeared above Earth before the age of satellites, the best place to search for it may not be in legends. It may be in the quiet archives of astronomy, in images taken by people who were not looking for mysteries, in records made before the question was even asked, in old photographs of the sky where light itself became evidence. And there, perhaps, a different kind of mystery was waiting, not painted by fear, not shaped by religion, not carried through rumor, but preserved in silver and glass. A story can survive for centuries. It can pass from one mind to another, from one page to the next, carrying with it the shape of a strange morning, a frightened crowd, a sky that seemed to behave in a way no one understood. But a story, no matter how haunting, is not the same as evidence. This is one of the most important steps in any mystery. It is also one of the hardest, because human beings love stories. We remember them more easily than numbers. We feel them more deeply than measurements. A single witness describing a light in the sky can move us in a way that a table of data cannot. A drawing from the past can stir the imagination more quickly than a graph or a catalog entry. Stories make the unknown feel alive, but science asks for something quieter, something slower, something that can be checked again and again and again. If a person says they saw a strange object above a city, that may be interesting. If several people say they saw it, that may be more interesting. But even then, we still have questions. Where exactly were they standing? What was the weather? What time was it? How bright was the object? How fast did it move? Was it seen from another city? Was it recorded by an instrument? Did it leave behind anything that could be studied? Without those answers, a sighting remains suspended between possibility and imagination. It may be true. It may be misunderstood. It may be exaggerated. It may be remembered incorrectly. It may be a real event wrapped in the language of fear. This does not make witnesses useless. Witnesses matter. They are often the first to notice that something unusual has happened. A witness can point our attention toward a mystery. A witness can say, "Look here, something in the sky was not ordinary." But after that first moment, we need more. A witness is like a candle in a dark room. A photograph is a window, and a dataset is a whole city of windows, each one opening onto the same night from a slightly different angle. That is why the search for strange lights changes when we leave old reports behind and enter the world of astronomy. Astronomy is, in many ways, the art of patient looking. A human eye glances upward and sees wonder. A telescope stares. It does not become excited. It does not feel fear. It does not interpret a light as a warning, a god, a machine, or a visitor. It simply gathers photons, tiny messengers that have crossed space, and brings them into focus. The telescope does not know what it has seen. It only records. And that makes it powerful. Not perfect, but powerful. In the age before digital cameras, astronomers used photographic plates to capture the sky. These plates were pieces of glass coated with light-sensitive material. When placed at the focus of a telescope, they could collect faint starlight over long exposures, revealing objects too dim for the eye to see. A plate might hold thousands of stars, tiny black or white points, depending on how the image was processed. Galaxies, nebulae, clusters, asteroids, variable stars, all pressed gently into a chemical surface by the falling of light. And once the exposure ended, that piece of sky was preserved. The night moved on. The stars shifted. Clouds came and went. The astronomer slept, but the plate remained, a frozen memory. A piece of the universe caught at one moment in time. This is very different from a story. A story can change as it is retold. A plate does not retell itself. It can be damaged. It can be misread. It can carry flaws. But it does not invent. It does not become more dramatic with age. It simply waits. And decades later, someone can return to it. Someone can compare it with another image. Someone can ask whether a point of light that appeared once is still there. This is where astronomy becomes a kind of time travel. Not the science fiction kind, with machines and paradoxes, but a quieter kind. A modern researcher can look at a photograph taken before they were born and see the sky as it was on one particular night. They can place that old sky beside a modern survey and ask what has changed. Most of the time, the answer is ordinary. A moving asteroid was in one place then and another place later. A variable star brightened and dimmed. A photographic flaw pretended to be a star. A catalog mismatch created a false mystery. The universe is rich in ordinary explanations, and ordinary explanations should always be welcomed first. They are the ground beneath our feet. But sometimes, after the ordinary explanations have been considered, a few questions remain. Not conclusions. Questions. A light that appears on one plate, but not on another. A group of points that flash into the record and then vanish. A source that should have a modern counterpart but does not. These are the places where science leans closer. Not because it already knows the answer, but because the answer is not yet obvious. This is why old astronomical archives are so valuable. They were created for one purpose, but later generations can use them for another. The astronomers who mapped the sky in the mid-20th century were not searching for unknown objects above Earth. They were building a record of the heavens. They were cataloging stars and galaxies. They were helping humanity understand the structure of the universe. But without knowing it, they were also preserving the pre-satellite sky. They were capturing a time before orbit became crowded. A time before every unexplained glint could be easily blamed on one of our own machines. and that makes their plates unusually important. If something strange appears there, we cannot simply shrug and say, satellite. We must ask more carefully. Was it a defect? Was it an asteroid? Was it a flare from a distant object? Was it contamination? Was it a natural event we do not yet fully understand? Or was it something moving near Earth, reflecting sunlight, at a time when nothing human was supposed to be there? The answer may still be ordinary, but the question is extraordinary, and the only way to approach it is not through legend, fear, or belief. It is through evidence, through patient comparison, through old glass, through modern surveys, through statistics, shadows, arguments, and doubt. This is where the story truly changes. We began with human beings looking up and wondering what the sky was trying to tell them. Now we move into a quieter world where the sky was not interpreted but recorded. A world of mountaintop domes, cold night air, careful exposures, and fragile plates stored away for decades. A world where a tiny point of light could wait half a century before becoming a mystery. And to enter that world, we have to climb a mountain in Southern California. A mountain where night after night, the universe was photographed in silence. High above Southern California, far from the restless lights of Los Angeles, there is a mountain where the night once became an archive. Mount Palomar rises quietly above forests, roads, and dry valleys. By day, it is a place of sunlight, stone, trees, and long views toward the horizon. But by night, when the air grows cooler and the last colors of sunset drain from the sky, the mountain seems to belong to another world. The dome opens, the telescope turns, and slowly, the universe begins to fall into focus. In the middle of the 20th century, Palomar Observatory was one of the great eyes of Earth. Its instruments were built for a simple but enormous purpose: to see deeper, farther, and more carefully than human eyes ever could. The astronomers who worked there were not looking for visitors. They were not searching for hidden craft. They were not trying to prove that something unknown had crossed above Earth. They were doing what astronomers had always done. They were mapping the sky. Patiently, systematically. Night after night, the telescope gathered light from stars, galaxies, nebulae, and distant clusters. Some of that light had traveled for years, some for centuries, some for millions of years, crossing emptiness so vast that the human mind can only approach it through imagination. And then, after that long journey, the light reached Earth. It passed through the atmosphere. It entered the telescope. It bent through glass and mirrors. And finally, it touched a photographic plate. Before digital detectors, before modern sky surveys filled databases with billions of measurements, astronomy depended on these fragile pieces of glass. A photographic plate was not just a picture. It was a physical memory of the sky. The plate was coated with a light-sensitive emulsion. During an exposure, the telescope would hold steady, tracking the slow rotation of Earth, while the stars pressed their faint signatures into chemistry. A bright star might leave a strong mark. A faint galaxy might appear as a soft blur. A cluster might look like dust scattered across blackness. And somewhere among all of it, tiny points could appear that no one noticed at the time. To imagine it properly, we have to slow down. Picture the observatory at night. The mountain air is cold. The dome is open to the sky. Inside, everything is quiet, except for the subtle movement of machinery and the careful work of the people guiding it. Outside, the stars stretch overhead in a darkness deeper than most cities will ever know. The astronomer prepares the plate. The exposure begins. For several minutes, perhaps longer, the telescope watches a particular patch of sky. Nothing dramatic seems to happen. No music, no thunder, no announcement from the universe. Only starlight, falling, a patient rain of photons. Each photon is almost nothing by itself, a tiny packet of light, a messenger without weight. But together, over time, they become an image. They become a record. They become evidence that something was shining in that direction, on that night, at that hour, from that place on Earth. Then the exposure ends. The plate is removed. Another plate may be prepared. Another field of sky may be captured. The night continues, and the archive grows. This is what makes the Palomar plates so beautiful. They are not only scientific tools, they are time capsules. Each one contains a piece of the sky before our modern age transformed it, before orbit filled with satellites, before the night became crowded with human reflections, before the simple phrase, "It was probably a satellite," became so easy to say. These plates preserved the old sky, almost by accident. They were made to chart the universe beyond Earth, but they also captured whatever happened to be between Earth and the stars. That is an important thought. When a telescope photographs the deep sky, it is trying to look outward. It wants galaxies, stars, nebulae, cosmic structure. But the light path is not empty. Anything passing through the field of view at the right moment can leave a trace. An asteroid, a meteor, a flaw, a dust grain, a scratch, a reflection, a transient event, a temporary light that appears once and is gone. Most of these traces have ordinary explanations. Astronomers are used to sorting them out. They know that the sky is full of motion, and that instruments are full of imperfections. A single mark on a plate does not automatically mean something extraordinary. But old plates can hold surprises, because they do not only show what astronomers expected to see. They show what was there, or at least what the instrument recorded as being there. And decades later, when those plates were digitized and compared with newer surveys, they became more than historical images. They became a way to ask the past a question. What was in the sky then that is not in the sky now? This question sounds simple, but it opens a deep door. A star should not usually vanish without a reason. A galaxy should not disappear from one century to the next. A bright source seen once should have some kind of explanation. Maybe it moved. Maybe it exploded. Maybe it dimmed. Maybe it was never a real source at all. Maybe it was only a flaw on glass. But to know which is true, someone has to look carefully. Someone has to compare old sky with new sky. Someone has to search through the silent memory of astronomy and ask which lights remain, which lights changed, and which lights seem to have slipped out of existence. That is what makes the old Palomar plates so powerful. They are not eyewitness testimony. They do not become afraid. They do not believe in omens. They do not care whether a shape resembles a craft, a star, or a scratch. They simply hold the marks they were given. And because they were created before the age of satellites, they give us something rare, a record of the sky when the space around Earth was still mostly free of human machines. Of course, this does not make them perfect. Glass can be damaged. Emulsion can age. Dust can mimic a star. A tiny defect can pretend to be a cosmic mystery. The process of copying, scanning, and digitizing a plate can introduce new problems. What looks like a point of light in a modern database may not always be a point of light in the original sky. This is why caution matters. The mountain photographed the universe, but it did not photograph it without noise. Still, there is a quiet power in these old records, because when a mystery appears in them, it is not just another strange story told by someone under the stars. It is a mark left in an astronomical archive, a point that can be measured, compared, debated, tested, and sometimes challenged. The plates from Palomar became part of a larger scientific memory, a memory stretching across decades, connecting the sky of the 1950s with the sky we observe today. And when modern researchers began searching that memory, they were not only looking for alien visitors, they were looking for things that had changed, sources that appeared, sources that vanished, stars that seemed to have been present in the old sky, but missing from the modern one. It is a strange feeling to imagine a star disappearing. Stars are supposed to feel permanent. They are the symbols we use for steadiness, for distance, for ancient time. And yet, in the archives, some lights seem to say otherwise. Some lights were there once, then gone. And the search for those missing lights would lead to an even stranger question. Not only why a star might vanish, but why a group of lights might suddenly appear, together, in a sky, photographed before satellites existed. Tiny points, brief reflections, silent marks on glass, waiting for someone, decades later, to notice them. A star is one of the most comforting things the human mind can imagine. It is distant. It is ancient. It seems steady. When we look up at night, the stars appear almost unchanged from one lifetime to the next. They were there before we were born. They will still be there after we are gone. They outlast our cities, our worries, our small seasons of light and shadow. For this reason, we often use stars as symbols of permanence. But in astronomy, even permanence is more complicated than it seems. Stars can change. They can pulse. They can flare. They can dim behind dust. They can explode in sudden brilliance. They can collapse into strange objects that no longer shine in ordinary light. Galaxies can host eruptions. Asteroids can drift through a field of view. Variable stars can brighten and fade like slow cosmic breathing. The universe is not a painted ceiling. It is alive with motion, violence, cycles, and surprise. So when astronomers speak of a vanished star, they do not always mean something impossible. They mean something that was once recorded, then later could not be found. And that is where a careful mystery begins. Decades after the Palomar plates were taken, researchers began using modern digital surveys to compare the old sky with the new one. This was not simply a romantic act of looking into the past. It was a scientific method. Take an old image of the sky. Take a modern image of the same region. Match the stars. Match the galaxies. Match the known objects. Then, ask a quiet question. What is missing? Most of the time, the answer is not dramatic. A source may have been a known asteroid that moved away. A bright mark may have been a defect in the plate. A star may have been variable, bright enough to appear once and too faint to appear later. A catalog may have misidentified something. A scan may have introduced a false point. The sky is not the only thing that changes. Our records change too. And old records, especially physical ones, have their own fragile lives. Glass can crack. Dust can settle. Chemical emulsions can age. Tiny imperfections can become magnified by digitization. A mark that looks celestial may have been born not in space, but in the plate records change too. And old records, especially physical ones, have their own fragile lives. Glass can crack. Dust can settle. Chemical emulsions can age. Tiny imperfections can become magn itself. This is why the search for vanishing stars is so difficult. It is also why it is so fascinating. Because if even one object truly appeared in the old sky and then vanished without an ordinary explanation, it would mean the universe had given us a rare event, perhaps a type of stellar death we do not fully understand, perhaps a failed supernova, where a massive star collapses into a black hole without the brilliant explosion we expect. Perhaps something stranger. The Vasco project, vanishing and appearing sources during a century of observations, was built around this kind of question. Its purpose was not to begin with aliens. It began with the sky, with records, with comparison, with the patient work of asking what had changed over time. Imagine it like this. The old Palomar plates are a memory from the middle of the 20th century. Modern surveys are a memory from our own era. Between them lies half a century or more. In that time, the universe has continued to move. Stars have aged. Asteroids have traveled. Galaxies have shifted only slightly, almost imperceptibly, in human terms. And Earth has changed its own surroundings completely, filling near space with satellites and debris. When researchers compare these two memories, they are not only comparing images, they are comparing eras. The old, quiet sky, and the modern, crowded one. At first, the idea of a missing star sounds almost poetic. A light once present has gone silent. A point in the heavens has been erased. But scientifically, the work is not poetic at all. It is careful, repetitive, and full of doubt. Each candidate must be checked. Is there a modern counterpart? Was the original source real? Could it have been a plate flaw? Was it near the edge of an exposure? Did another survey see it? Could a known object explain it? Science moves slowly through mysteries because it has to. It does not ask only, what is the most exciting explanation? It asks, what is the most likely explanation? Then, what else could have produced this? Then, can anyone else confirm it? And only after many ordinary doors have closed does the extraordinary door become worth opening. This is the rhythm that makes the search for vanishing stars so different from old sky legends. A legend begins with wonder. A scientific search begins with doubt. Doubt is not the enemy of mystery. Doubt is what keeps mystery honest. And in the old sky surveys, there were enough unusual cases to keep researchers looking. Some sources from older catalogs could not be found in modern observations. Some appeared to be present in one era and absent in another. Most would likely have ordinary explanations, but the possibility remained that a small number might represent rare astronomical events. A star that vanished without a bright explosion. A transient flash from a distant object. A brief outburst that happened to be captured once and never again. These would be valuable discoveries, even if they had nothing to do with life beyond Earth. The universe does not need aliens to be strange. It is strange already. A black hole can hide where a star once shone. A neutron star can spin hundreds of times per second. A dead star can steal matter from a companion and erupt. A distant galaxy can brighten for a moment because something massive bends its light. The sky is filled with events that would have sounded impossible before science gave them names. So the search continued. Old plates, modern images, candidate lists, cross-checks, eliminations, and then, within this larger search for sources that vanished, another kind of event drew attention. Not a single star missing from the modern sky. Not a slow change over decades, but brief points of light that appeared suddenly in old images and then disappeared. Transient lights, temporary lights, lights that did not seem to belong permanently to the sky behind them. This was different. A vanished star asks why something once steady is now gone. A transient asks why something appeared at all. It is a more delicate question, because a transient can have many causes. A cosmic ray, a plate defect, a scratch, a flare, an asteroid, an aircraft, a processing artifact, a real astronomical event, a false mark that only looks real because time has hidden its origin. But one case would become especially haunting. A photographic plate from 1950. A small region of sky. 9 points of light. Present in one image. Absent before. Absent after. And absent from modern surveys. Not one mysterious dot. Not two. 9. Together. Like a small cluster of silent sparks, appearing briefly in the old record of the heavens and then slipping away. For researchers, it was not enough to say they were strange. They had to ask what could create them. For us, following the mystery slowly through the dark, they mark the moment when the story becomes sharper. Because these 9 lights did not merely suggest that something had vanished. They suggested that something had appeared. Briefly, quietly, above an Earth that had not yet launched its first satellite. And that is where the old glass begins to feel less like an archive and more like a doorway. In the old astronomical records, most mysteries begin quietly, not with a dramatic signal, not with a message, not with a shape crossing the moon or a craft descending from the stars, but with a tiny mark, a dot. A small point of light where a point of light should not be. And sometimes, the most unsettling thing about such a mark is how easy it would have been to miss. A researcher turns through the data. A scanned plate appears on a screen. Thousands of stars fill the image. Most are ordinary. Most belong there. Most can be matched to known objects, modern surveys, catalog entries, and predictable motions. But then, in one old image from 1950, there are 9 lights. 9 small points. Not large. Not dramatic. Not shaped like anything. Just points. The kind of points the sky is already full of. And yet, these did not behave like normal stars. They appeared in one photographic plate. They were not visible in an exposure taken before. They were not visible in later records. They were not found in modern sky surveys that should have seen persistent stars or galaxies in the same positions. They were there once. And then they were gone. This is the kind of detail that seems simple until you sit with it. One unexpected point of light might be dismissed quickly. A scratch, a dust grain, a chemical flaw, a cosmic ray. A small imperfection in the plate. 2 points might still be coincidence. Old glass has many ways of misleading us. But 9 points, appearing together in the same old image, and then disappearing from the sky, invite a slower kind of attention. Not belief. Attention. There is a difference. Belief rushes forward. Attention stays still. It looks carefully. It asks what might have happened. And the first possibilities are ordinary ones. Perhaps the plate was contaminated. Perhaps something happened during development. Perhaps tiny particles touched the emulsion. Perhaps a flaw in the material created marks that looked like stars. Perhaps the digitized version made the points seem more meaningful than they were on the original glass. Perhaps the lights were not in the sky at all, but only in the fragile surface that recorded the sky. This is always the first door we must open. Because photographic plates are physical objects. They age, they gather damage. They carry the history of their storage, handling, copying, scanning, and preservation. A mark on a plate can be a record of starlight, or it can be a record of dust. The difficulty is telling one from the other. But the 9 lights continued to be interesting because they did not look random in the way simple damage often does. They appeared like small point sources, similar to stars, yet without the permanent presence that stars usually have. If they were real lights in the sky, they had to be temporary, transient, appearing for a short time, then fading or moving away. Astronomy has many transient events. A star can flare. A distant explosion can brighten. An asteroid can pass through a field. A meteor can leave a streak. A variable object can rise above detection limits, and then fall below them. The universe is not still, but these 9 lights raised a particular problem. They appeared close enough in time and space to suggest a shared cause. If they were distant stars or galaxies, why would they all appear together and then vanish? If they were asteroids, where was the motion? If they were aircraft, why did their signatures not resemble ordinary trails? If they were gamma-ray bursts or distant cosmic explosions, why would there be 9 of them in one small region at once? Every possible answer had difficulties. None had to be impossible, but none was immediately satisfying. And that is often where a scientific mystery becomes truly interesting. Not when there is no explanation at all, but when every explanation leaves something behind. A loose thread, a shadow, a detail that refuses to fit perfectly. Among the possibilities, one was especially strange. What if the 9 lights were not stars at all? What if they were brief reflections, glints, tiny flashes of sunlight bouncing off objects high above Earth? This is something we understand very well today. A satellite can be invisible one moment and bright the next. It may pass through sunlight while the observer below stands in darkness. A flat metallic surface, a solar panel, or a tumbling body can catch the sun at just the right angle and create a sudden flash. For a few seconds, or minutes, it may appear like an extra star. Then the angle changes. The reflection vanishes. The object continues silently through orbit. To a modern observer, this is not strange. We know the sky contains machines. We expect them to flash. But the plate in question came from 1950. And in 1950, the official sky had no human satellites. That is why the idea feels so uncomfortable. Not because it proves anything. It does not. But because it takes a familiar modern explanation and places it in a time where that explanation should not easily belong. Imagine a dark room full of old photographs. Each photograph shows a different night. Most are quiet. Most contain only what they should contain. Then, in one image, there is a reflection of something that looks like a machine. But the photograph was taken before the machine was invented. You do not have to believe the impossible to feel the strangeness of that. You only have to understand the timeline. The year 1950 sits in an unusual place. It is after the Second World War. After radar. After the first atomic bombs. After rockets had begun to move from weapons into dreams of space travel. But it is before Sputnik. Before orbit became a place of human activity. Before the familiar clutter of satellites and debris, it is a threshold year. A year standing just outside the doorway of the space age. And on one old plate from that threshold, 9 lights appear. For a sleep story, this is where we might imagine the scene not as a laboratory result, but as a quiet moment in the life of the sky. Above Earth, the planet turns. Clouds move slowly over oceans. Cities glow faintly below. The sun shines on one side of the world while night covers the other. Somewhere high above the atmosphere, if the reflection hypothesis is correct, small objects catch the sunlight for a moment. Not long, only briefly. A glimmer. A flash. A message with no language. Then the angle changes, or the objects move, or the shadow of Earth takes them, and the lights are gone. Below, on a mountain in California, a photographic plate keeps the memory. No one hears anything. No one looks up and points. No one knows that decades later, those 9 tiny marks will become part of a debate about the old sky, the beginning of the space age, and the possibility that something was moving above Earth before our own machines arrived. This is what makes the case so haunting. The lights do not speak. They do not explain themselves. They do not form a symbol. They do not spell a message across the stars. They are almost nothing. And yet, in science, almost nothing can matter. A small wobble in a star can reveal a planet. A faint dimming can reveal a world crossing its sun. A tiny distortion in light can reveal invisible mass. A brief flash can reveal an explosion billions of light-years away. The universe often whispers before it becomes understood. So the 9 lights must be treated gently. They may be defects. They may be artifacts. They may be natural. They may be nothing more than old glass pretending to hold a secret. But if they were real lights above Earth, then the question deepens. Because something reflected sunlight in the pre-satellite sky. Something appeared where no lasting star remained. Something left only a temporary trace. And the next question becomes unavoidable. If they looked like satellite glints, how could they appear before satellites existed? The word satellite feels ordinary now. It belongs to weather forecasts, maps, phones, television, internet signals, and the quiet machinery of daily life. We use satellites without thinking about them. They guide us through unfamiliar streets. They help ships cross oceans. They measure storms before they reach land. They photograph forests, deserts, ice sheets, and cities. They make the modern world feel connected, watched, measured, and mapped. But there was a time when the word still carried wonder. A satellite was not yet a tool. It was an idea, a possibility, a dream waiting above the atmosphere. Before October of 1957, no human-made object had officially completed an orbit around Earth. Rockets had flown. High-altitude experiments had reached upward. Engineers had imagined the future. Science fiction writers had filled the heavens with stations, ships, and artificial moons. But the real sky was still waiting. Then Sputnik rose. A polished metal sphere, small enough to fit in a room, crossed into orbit and changed the meaning of the night. For the first time, Earth had an artificial companion. For the first time, something built by human hands circled the planet again and again, above borders, above oceans, above sleeping cities. Its radio signal was simple, a repeating beep. But to the world below, it sounded like the beginning of a new age. After Sputnik, the sky could no longer be understood in the old way. From that point forward, humans had entered orbit, and orbit would never be empty again. More satellites followed, larger, heavier, more capable. Some watched the weather, some listened for signals, some carried cameras, some carried scientific instruments, some were built for communication, some were built for war, some were built openly, others were built in secrecy. Then came rocket bodies, spent stages, fragments, debris, lost tools, broken panels, dead satellites, and thousands of objects moving silently around Earth. The sky acquired a new layer, a human layer, a bright mechanical dust. This is why the date matters so much. When a strange point of light appears in a photograph after 1957, we have to consider satellites. We have to consider space debris. We have to consider reflections from objects we placed above the atmosphere. Even if we do not know exactly which object caused the flash, the category exists. Human technology is available as an explanation. But in 1950, that explanation becomes much harder. Not impossible in the absolute sense, because history always has shadows. There were secret programs, there were military experiments, there were captured rockets, there were balloons, test vehicles, and ambitions that governments did not always make public. But a stable artificial object in orbit before Sputnik would be a very different claim. It would require evidence, strong evidence, careful evidence, evidence much stronger than a few points of light on old photographic plates. And so we return to the uncomfortable middle ground. The 9 lights do not prove that something artificial was orbiting Earth. They do not prove a hidden human satellite. They do not prove a non-human craft. They do not prove visitors watching from above. But they do remove the easiest modern answer. We cannot simply say, it was probably a satellite. In the ordinary way, we might say that today. The timeline pushes back. It asks us to slow down. It asks us to look at the sky of 1950 as it was, not as our modern minds expect it to be. This is one of the deepest challenges in thinking about the past. We carry the present with us. When we imagine a point of light moving across the night, we imagine satellites because we live under satellites. When we imagine a sudden flash high overhead, we imagine metal panels, tumbling debris, orbital paths, and sunlight catching the edge of technology. But people in 1950 did not live beneath that kind of sky. Their sky had aircraft below, balloons within the atmosphere, meteors entering from space, planets and stars beyond, but not the familiar population of orbiting machines that now surrounds us. So if something in an old plate resembles a satellite glint, we have to ask whether the resemblance is meaningful or misleading. This is where mystery can become dangerous, because the human mind loves patterns. It sees faces in clouds, animals in constellations, messages in coincidence. A tiny bright point that looks like a reflection may not be a reflection at all. It may simply be a defect shaped by chance into something suggestive. A cluster of marks may appear connected because we notice them together. A strange timing may seem profound because we have arranged the story around it. Science must protect us from that. It must keep asking the uncomfortable questions. What if the lights are plate flaws? What if the original glass holds evidence of damage? What if the digitized scans exaggerated the points? What if cosmic rays, contamination, or emulsion defects created a pattern that only looks astronomical? What if the mystery belongs not to the sky, but to the archive? These are not boring questions. They are necessary ones. Because if the answer is ordinary, we should want to know. An ordinary truth is better than an extraordinary illusion. And yet, if the answer is not ordinary, we should want to know that too. This is the balance the entire mystery rests upon. On one side, caution. On the other, wonder. The old lights stand between them. They ask us not to believe too quickly, but also not to look away too easily. There is something haunting about a light that seems to arrive before its time, a reflection before the age of reflectors, a satellite-like glint before satellites, a small bright mark in the old sky, sitting quietly in the wrong chapter of history. Perhaps it is only a coincidence. Perhaps it is a flaw. Perhaps it is a natural event with a name we have not yet connected to it. But the feeling remains. The feeling that, for a moment, the past has shown us something out of place. Imagine an old photograph of an empty road taken in the 19th century. Horses, dirt, wooden buildings, long shadows. Then, in one corner, there appears what seems to be the reflection of a modern car. The first explanation should not be time travel. The first explanation should be damage, misidentification, a later mark, a trick of light, a misunderstanding. But still, the mind would stop. The mind would lean closer. Not because it believes the impossible, but because the image has asked a question the timeline does not easily answer. That is what the pre-Sputnik lights do. They interrupt the timeline. They appear in a sky that should not yet have contained the thing they seem to resemble. And for a mystery like this, resemblance is not enough. Researchers need a way to test whether the lights behaved like real objects above Earth or like flaws trapped in the plate. They need something larger than opinion. something that does not depend on whether a point looks interesting, something written into the geometry of Earth, sunlight, and shadow. Because if an object high above Earth is truly reflecting the sun, then it should obey the rules of light. It should brighten when sunlight reaches it. It should fade when the angle changes. And if it passes into the night cast by our own planet, it should disappear. This brings us to one of the most elegant parts of the investigation. Not a secret witness, not a rumor, not a dramatic claim, but a shadow, the shadow of Earth. Every night, our planet carries a cone of darkness behind it, a long silent region where sunlight cannot reach. If the old transients were only defects on glass, Earth's shadow should mean nothing to them. A scratch does not know where the sun is. Dust does not care whether the planet blocks the light. A chemical flaw does not vanish because it has entered night. But a reflective object in space would care. It would shine only while the sun could touch it. And so, to ask whether the lights might have been real objects above Earth, researchers turned to the simplest darkness in the sky, the darkness made by Earth itself. Every night, Earth makes a shadow. We rarely think about it this way. Standing on the ground, night feels like something that falls over us. The sun sets, the sky darkens, the stars appear, the world grows quiet. We say that darkness has come. But from space, night is not something that falls. It is something Earth carries. Our planet turns in sunlight, half bright and half dark. On one side, oceans glitter, clouds glow, mountains cast short shadows across the land. On the other side, cities begin to shine, storms flicker, and the surface slips into blue and black. Behind the planet, stretching away from the sun, there is a long cone of darkness, Earth's shadow, a silent tunnel of night reaching into space. Anything that enters that shadow loses direct sunlight. The moon does this during a lunar eclipse, when it passes through Earth's darkness and turns copper red. Satellites do it every day, brightening when they catch sunlight and fading when they move into the planet's shadow. Space stations, rocket bodies, and tiny fragments of debris all obey the same geometry. They shine only when light reaches them. This simple fact gives us a powerful test. If a strange point of light on an old photographic plate is only a flaw, then Earth's shadow should not matter. A scratch on glass does not know whether it was night in space. A dust grain does not care where the sun was. A chemical imperfection in an old emulsion does not become more or less likely because Earth blocked the sunlight from a certain region above the planet. But a real reflective object would be different. If it were high above Earth, catching the sun for a brief moment, then its visibility would depend on where it was in relation to the sun and the planet's shadow. In sunlight, it might flash. In shadow, it should disappear. Or at least, become much harder to see. This is why the shadow test is so elegant. It does not begin with belief. It does not ask whether the lights look mysterious. It asks whether they behave as if sunlight is involved. Imagine a small metallic object far above the atmosphere. It may be dark most of the time, too small to see, too distant, too quiet. But if one flat surface catches the sun at just the right angle, it can throw a tiny glint toward Earth. For a moment, a telescope might record it as a point of light. Then the object moves, or the angle changes, or Earth's shadow covers it, and the glint is gone. To someone looking at the image decades later, the object itself is invisible. Only the flash remains, a brief mark, a temporary star, a light without a lasting source. Now imagine many such flashes across many old plates. If they are real reflections from objects near Earth, they should not be spread randomly through all conditions. There should be fewer of them where sunlight cannot reach. The shadow of Earth should leave a fingerprint in the data, not a message, not a shape, A statistical absence, a quiet reduction, a place in the sky where the lights appear less often because, if they are reflections, the sun has been taken away. There is something beautiful about this idea. It turns darkness into a tool. The same shadow that gives us night becomes a way of asking whether old lights were ever truly in space. Not everyone agrees on what the answer is. Some researchers have argued that there appears to be a reduction of certain transient lights in the region of Earth's shadow, which would support the idea that at least some of them might have been sunlight reflections from objects above the atmosphere. Others have challenged that conclusion. They have argued that the result depends heavily on how the data are selected, cleaned, filtered, and interpreted. If the sample includes too many questionable points, flaws may masquerade as a pattern. If the sample is filtered too strictly, perhaps genuine but rare events are thrown away. The debate becomes not only about the sky, but about the process of deciding which points in the data deserve to be trusted. This is science in its slowest form. Not a single dramatic revelation, but a careful disagreement over details. Which lights count? Which should be removed? Which plates are reliable? Which apparent sources are stars, defects, scratches, or real transient events? How do we know the shadow effect is not created by the way the data were gathered? How do we separate the universe from the instrument? These questions may sound technical, but they matter deeply, because extraordinary mysteries can hide inside ordinary mistakes. A small bias in a dataset can become a strange signal. A scanning artifact can become a false star. A damaged plate can become a cosmic question. And yet, the reverse is also true. A real anomaly can be dismissed too quickly if it appears in old or imperfect data. A fragile clue can be lost if we demand that the past meet the standards of instruments it did not have. So we are left in a delicate place. The Earth's shadow may be a clue, or it may be a disputed pattern. It may help separate real reflected objects from photographic noise, or it may vanish when the data are handled differently. But even the attempt to use it tells us something important. It tells us that the mystery has moved far beyond simple storytelling. We are no longer in the streets of Nuremberg, looking up at a frightening dawn. We are no longer asking only whether people once saw something strange. We are now asking whether old points of light obeyed the geometry of sunlight and shadow. That is a different kind of mystery. A colder one, a quieter one, and perhaps a more serious one. Because if some of these lights truly avoided Earth's shadow, or appeared more often where sunlight could touch objects above the planet, then they may not have been stars at all. They may not have belonged to the deep background of the universe. They may have been nearby, close to Earth, moving through the space above us before the human sky became crowded. That possibility is not proof. But it is enough to make the old plates feel deeper, as if the photographs did not only capture the distant cosmos, but also a hidden layer just above our world, a layer between Earth and the stars. A place where something small, silent, and reflective might have crossed through sunlight, flashed once, and vanished into shadow. And as researchers looked more closely at these old transients, another pattern was proposed. A pattern not written in the geometry of Earth's night, but in the darker history of the 20th century. Because the same years that preserved the pre-satellite sky were also the years when humanity began to light the Earth with nuclear fire. The sky of the 1950s was quiet in one way, but Earth was not. Below the old stars, below the calm photographic plates, below the patient domes of observatories, humanity had entered one of the most dangerous chapters in its history. The nuclear age had begun. For the first time, a species on Earth had learned how to release the energy hidden inside the atom, not as a theory, not as a dream, but as fire bright enough to erase cities, reshape politics, and change the way civilization thought about its own future. The planet had become louder, not louder in the ordinary sense, not with sound, but with signals. Radar swept through the atmosphere. Radio waves leaked into space. Rockets climbed higher. Military aircraft crossed oceans. Secret laboratories worked through the night. Governments watched one another from behind walls of fear. And sometimes, in remote deserts and isolated islands, the surface of Earth flashed with artificial suns. For anyone looking at our planet from far away, if such an observer existed, the middle of the 20th century would have looked different from everything that came before it. For millions of years, Earth had been a living world. Blue oceans, white clouds, green continents, lightning storms, volcanic eruptions, the slow pulse of seasons. Then, suddenly, there were signals that did not come from weather or geology. There were radio transmissions, radar beams, nuclear flashes, signs that something on this planet had learned to disturb nature on a planetary scale. This does not mean anyone was watching. It only means that if someone had been watching, this would have been a difficult era to ignore. And that is why the proposed connection between strange old transients and nuclear testing feels so haunting. Some researchers have suggested that certain transient lights in the old astronomical plates may have appeared more often around periods of nuclear tests. Others have argued that this apparent pattern may be caused by how the data were selected, how often the telescope was observing during those windows, or by ordinary flaws in the plates themselves. The debate is not settled, and we should not pretend that it is. But as a story, as a question, as a quiet thread running through the old sky, the timing is difficult not to feel. The years before Sputnik were not empty years. They were threshold years. Humanity had not yet filled orbit with satellites, but it had already changed the meaning of Earth. We were still below the sky, but we were beginning to announce ourselves to the universe. Imagine the planet at night from far above. The cities are smaller than they are today, but they are spreading. Coastlines glow faintly. Roads connect towns like thin lines of amber. Ships move across dark oceans. Storms flicker in the atmosphere. And then, somewhere on the surface, there is a flash. Brighter than ordinary fire. Brighter than lightning in its meaning, if not always in its duration. A man-made sunrise blooming over desert dust or ocean mist. Then darkness returns. The Earth continues turning. Clouds cover the wound. The stars remain silent. If there were objects above Earth at that time, natural, artificial, or unknown, they would have looked down on a civilization crossing a boundary. A civilization that had discovered enough physics to reach toward space, and enough destructive power to threaten itself before it arrived there. This is one of the reasons nuclear history appears so often in discussions of unidentified aerial phenomena. There are stories, reports, and claims that strange objects seemed interested in nuclear sites, missile fields, weapons facilities, and test ranges. Many of these stories are difficult to verify. Some are based on witness testimony. Some are disputed. Some may contain misunderstandings, classified human activity, or ordinary events made strange by secrecy and fear. But the association has persisted, not as proof, as a pattern people keep returning to, because it feels logical in a dark way. If there were an intelligence watching Earth, what would draw its attention? Not our buildings, not our borders, not our speeches. Perhaps the moment when we learned to split the atom. Perhaps the moment when a young technological species became dangerous, not only to other life, but to itself. Still, feeling logical is not the same as being true. This is where the story must remain careful. A correlation in old data is not a cause. A strange timing is not a message. A flash on a photographic plate near the era of nuclear testing does not mean a craft was observing the test. History is full of coincidences that feel meaningful after the fact. And the more emotionally powerful a subject becomes, the more easily the mind begins to connect dots that may not belong together. The nuclear age is emotionally powerful. It carries fear, secrecy, extinction. The sense that humanity stepped too quickly into knowledge it was not yet wise enough to hold. So when strange lights appear in the same broad era, we must be careful not to let the darkness of the history color the evidence more than it should. The old plates do not show intentions. They do not show concern. They do not show watchers. They show points of light, temporary marks, possible transients, possible flaws, possible reflections. That is all. And yet, sometimes, that is all is enough to keep a question alive. Because the mystery is not only about whether these lights were connected to nuclear testing, it is about the kind of world they appeared above. A world between ages. Below, humanity was splitting atoms. Above, the orbit of Earth was still officially empty. Below, nations were building weapons that could end cities. Above, the old sky was being photographed in silence. Below, radio and radar signals were beginning to leak outward. Above, if the strange lights were real, something may have briefly reflected sunlight in the darkness. The contrast is almost dreamlike. Earth shouting, space silent, humanity becoming visible, the sky keeping its secrets. Perhaps the connection with nuclear testing will eventually disappear under better data. Perhaps it will be explained by observation schedules, plate defects, statistical noise, or the complicated habits of old archives. That would not be failure. That would be science doing its work. But perhaps some part of the mystery will remain. A small residue. A handful of lights that do not fit comfortably into the ordinary boxes. And if that happens, the nuclear age will remain part of the atmosphere of the question. Not proof that someone came because of our weapons, but a reminder of what Earth was becoming at the time those old photographs were taken. A young world, technologically speaking, brightening, broadcasting, testing fire, dreaming of space, afraid of itself, and perhaps, under the patient eyes of old telescopes, leaving behind a few tiny flashes that still ask us to look upward and wonder whether the sky above the nuclear age was as empty as we thought. But the more powerful the possibility, the stronger the doubt must become. And so, after the shadows, after the glints, after the strange timing of history, the skeptics return to the plates, to the glass, to the scans, to the flaws, to the uncomfortable possibility that the mystery was not above Earth at all, but inside the fragile records we used to remember it. Every mystery has a moment when wonder must step aside and let doubt enter the room. Not to destroy the mystery, but to test it, to place it under colder light, to ask whether what seems extraordinary may have been created by something small, ordinary, and easily overlooked. The strange lights in the old Palomar plates are no exception. For some, they suggest an almost impossible question. Could there have been reflective objects above Earth before the first human satellites? Could something have glinted in sunlight, high above the atmosphere, at a time when orbit was supposed to be empty? But for others, the answer may lie much closer to home. Not in space, not in orbit, not in the silent region between Earth and the stars, but in the plates themselves. Old astronomical photographs are beautiful, but they are not flawless windows. They are physical objects. They have surfaces. They have chemistry. They have histories. They were handled by human hands. Stored in archives. Copied. Scanned. Digitized. Compressed into data. And every step between the night sky and the modern computer screen creates a place where error can enter. A tiny scratch may look like a streak of light. A dust grain may become a point source. A flaw in the photographic emulsion may resemble a faint star. A mark made during development may survive for decades, waiting to be mistaken for something cosmic. Even the process of scanning old plates can create artifacts, digital ghosts born not from the sky, but from the machine trying to preserve the sky. This is why skeptics ask for caution. They are not always saying the mystery is foolish. They are saying that the path from glass to conclusion is long, and every step must be checked. If a small bright point appears on a digitized image, the first question is not, what was flying above Earth? The first question is, was it ever in the sky at all? This is a difficult question because the sky and the plate are now fused together in the record. When we look at the image, we see stars and possible flaws in the same field. Both appear as marks. Both occupy space. Both can be measured, but only one belongs to the universe. To separate them, researchers need careful methods. They need to compare multiple exposures. They need to inspect original plates when possible. They need to ask whether a point has the same shape as nearby stars. They need to check whether it appears in other colors, other surveys, other times. They need to know whether the supposed transient sits near the edge of a plate, near a known defect, near a bright star, or in a region where scanning errors are common. They need to build catalogs. Then question the catalogs. Filter the data. Then question the filters. Because a mystery can be created not only by what is present, but by what is removed. If the data set is too loose, it may include too much noise. Dust, scratches, defects, and false detections may gather together until they look like a pattern. But if the data set is too strict, it may remove the very thing being searched for. Rare transients may be thrown away because they do not behave like ordinary stars. Real anomalies may disappear under the pressure of cleaning. This is the uncomfortable balance. Too much trust, and the archive becomes a haunted sky. Too much skepticism, and the sky becomes silent before it can speak. The debate around these old transients lives inside that balance. Some researchers argue that the patterns are meaningful, that certain lights appear to behave as if they were real reflections, perhaps even affected by Earth's shadow, perhaps connected in some way with historical timing. Other researchers argue that the evidence has not survived stricter tests. They suggest the apparent patterns may come from data selection, observational bias, plate defects, catalog contamination, or the complicated imperfections of old astronomical surveys. This disagreement is not a side detail. It is the heart of the mystery. Because without a reliable way to separate true sky events from archival artifacts, even the strangest lights remain uncertain. Imagine finding a footprint in ancient dust. If the footprint is real, it changes the story of who was there. But before that, you must ask whether it is a footprint at all. Could it be erosion? A crack? A shadow? A mark left by a tool? A pattern the eye has turned into meaning? Only after those questions can the larger story begin. The old Palomar transients are like that. Possible footprints in the sky. But the ground is glass, and glass remembers many things besides starlight. This is why some scientists call for direct inspection of the original plates. A microscope may reveal whether a mark is embedded in the emulsion like a genuine exposure, or whether it sits on the surface as damage or contamination. The original glass may hold clues that a digital scan cannot fully preserve. In a way, this brings the mystery back from the vastness of space to something almost intimate. A scientist leaning over an old plate. A small light under a microscope. A question hidden in a mark smaller than a grain of dust. Was this made by the universe or by time? There is no shame if the answer is time. Many mysteries end that way. Not with revelation, but with a scratch. Not with visitors, but with chemistry. Not with something watching Earth, but with the quiet aging of human records. And yet, even that kind of ending can be meaningful. Because science does not lose when it finds an ordinary answer. It wins. It becomes clearer. It removes one shadow from the room. But what if not all the shadows disappear? What if most of the lights are defects, but a few remain difficult? What if the old plates contain a mixture, noise, flaws, ordinary stars, and a small number of events that still resist explanation? That is where the mystery stays alive, not in certainty, but in residue, in the few cases that remain after the easy answers are removed, in the small unsolved fragments that do not yet fit. This is why the skeptical view does not weaken the story, it strengthens it. A mystery that cannot survive doubt is not a strong mystery, but a mystery that remains interesting after doubt has done its work deserves attention. So we should let the skeptics look again. Let them question the plates. Let them challenge the statistics. Let them inspect the glass, rebuild the datasets, compare the surveys, and remove every false light they can find. And after that, if nothing remains, then the sky has given us an answer. But if even a few lights remain, if even a handful still sit quietly outside the ordinary explanations, then the question becomes deeper, not smaller. Because we would no longer be asking whether every strange dot was meaningful. We would be asking why any of them were. And that is the place where our journey now turns, away from the argument itself, away from the numbers, the filters, the plates, and the counterclaims, toward the quiet possibility that has been waiting beneath the entire story. If something was really there, above Earth, before the age of satellites, what could it have been? If something was there, above Earth, before the age of satellites, then the question becomes almost too large to hold. What was it? That is the question waiting at the center of every strange light, every old plate, every disputed transient, every argument over glass, shadow, and data. And the honest answer is simple. We do not know. Not yet. Perhaps we never will. Some mysteries fade not because they are solved, but because the evidence is too fragile to carry them any further. An old plate can be inspected only so many times. A mark can be measured, compared, challenged, defended, and questioned. But the original moment is gone. The sky that created the image has moved on. The Earth has turned through decades of nights since then. Whatever happened, happened once. Then it vanished into time. Still, we can stand beside the question quietly and look at the possibilities. The first possibility is the most ordinary. The lights may have never been in the sky at all. They may have been tiny failures of chemistry, marks in the emulsion, dust, scratches, contamination, or artifacts introduced by copying and scanning. They may have looked like stars only because old glass can imitate the universe in subtle ways. This would not be a disappointing answer. It would be a clean one. It would mean the sky before satellites was as empty of machines as we thought, and the mystery belonged not to orbit, but to the delicate materials we use to record the heavens. There is something almost poetic in that too. A false star born inside glass. A tiny scar mistaken for a cosmic event. A human archive dreaming that it remembered more than it did. The second possibility is that the lights were real, but natural. The universe is full of temporary brightness. Things flare, reflect, erupt, collapse, and vanish. Small bodies move through space. Distant objects brighten for reasons that may be rare but not impossible. Atmospheric effects can mislead instruments. Near-Earth objects can catch light in unexpected ways. There may be phenomena we do not yet understand well enough to recognize in old data. This would also be a beautiful answer, because it would remind us that nature is stranger than our categories. A natural explanation is not a small explanation. A comet is natural. A black hole is natural. A neutron star is natural. A galaxy collision is natural. Nature is capable of creating events that once would have sounded like magic, prophecy, or impossible machinery. Perhaps the strange lights belong to that kind of future understanding. Something ordinary to the universe, but not yet ordinary to us. The third possibility is more difficult. Perhaps some lights were reflections from objects near Earth, not necessarily alien, not necessarily designed. Perhaps small natural bodies, fragments, or materials moving in ways we do not easily reconstruct. Perhaps something in high orbit or near Earth space, catching sunlight for a brief moment before fading. This idea is strange because the timing is strange. Before Sputnik, Earth was not supposed to have artificial satellites, but near-Earth space was not truly empty. Natural objects pass near us. Meteoroids enter the atmosphere. Dust exists. Small bodies cross Earth's neighborhood. The region above us was not crowded with human technology, but it was never a perfect vacuum. Could something natural have reflected sunlight like a small mirror? Could multiple objects have produced brief glints? Could a rare alignment have created temporary points that looked more artificial than they were? Perhaps. But each possibility asks for more evidence than the old plates may be able to give. And then there is the fourth possibility, the one that brings us to the edge of the question everyone feels but few scientists want to state too quickly. What if some of the lights were not ours? What if, before humanity placed its first machine into orbit, something else had already moved through the space above Earth? Not necessarily a fleet, not necessarily visitors landing in fields, not necessarily the stories people have told for decades, maybe only small objects, silent, reflective, unidentified, present for a moment in sunlight, then gone. This is the possibility that changes the emotional shape of the mystery. Because if even one old transient were proven to be a real artificial object in near-Earth space before the space age, and not made by us, then the question would no longer be only astronomical. It would become historical, biological, philosophical. It would ask what kind of intelligence could cross the distances between stars. It would ask why such an intelligence would come near Earth. It would ask how long it had been watching, and it would ask what we looked like from above. That may be the deepest part of the story. Not whether something was there, but what Earth was if something was looking. Imagine our planet in the middle of the 20th century, blue and white, turning slowly in sunlight. A world of oceans, clouds, forests, deserts, ice, and storm systems curling over the continents. A living planet, a rare planet. A planet with radio noise rising from its surface, cities glowing brighter each decade, aircraft crossing the atmosphere, radar pulses reaching outward, nuclear tests flashing in remote places like brief artificial dawns. And beneath all of it, a young technological species trying to understand what it had become. We often imagine ourselves as observers of the universe. We build telescopes. We map galaxies. We listen for signals. We send probes outward. We ask whether life exists somewhere else. But this mystery gently reverses the direction of the gaze. It asks what it would mean if, at some point, Earth was not only looking, Earth was being looked at. That idea does not need to be frightening. It can be humbling. Perhaps any intelligence capable of crossing interstellar distances would see us not as enemies, not as equals, not as a threat, but as something young, a species just beginning to touch the sky. A civilization that had learned the mathematics of atoms before the wisdom to live peacefully with them. A world bright with promise and danger. From far above, our conflicts would look small, but our weapons might look significant. Our borders would vanish beneath clouds. Our languages would blend into radio noise. Our cities would shine like scattered embers on the night side of the planet. And perhaps that is why this question stays with us. Because it is not only about aliens, it is about perspective. From the ground, humanity feels central. Our lives feel enormous. Our fears, our nations, our histories, our ambitions, they fill the horizon. But from orbit, Earth is small. From the moon, smaller. From another star, almost nothing. A pale point of light. And yet, on that point, there are minds looking outward. Minds asking whether they are alone. Minds building machines, telling stories, making mistakes, and leaving records on glass. If something was there before Sputnik, perhaps it saw not a finished civilization, but the beginning of one. A species at the edge of the ocean of space, still standing on the shore, still afraid of the waves, still unaware of what might be moving beyond the dark. Or perhaps no one saw us at all. Perhaps the old lights are only flaws. Perhaps the question is only a mirror we have made for ourselves. But even then, the mirror is useful. It shows us how deeply we want to know whether the universe is aware of us. It shows us how much meaning we place in a small point of light. It shows us that the sky remains one of the few places where wonder and doubt can stand together without destroying each other. So we do not need to force an answer. We can let the mystery breathe. We can leave room for scratches on glass, unknown natural events, rare reflections, and possibilities we are not yet ready to name. We can admit that the evidence is incomplete. We can admit that the arguments are still open. And we can still feel the quiet power of the question. Because before satellites, before the crowded orbit of the modern age, before we surrounded Earth with our own machinery, the old sky may have held a few brief lights that do not yet belong to any final explanation. And whether they were nothing, or nature, or something stranger, they remind us that the sky above Earth has never been only empty space. It has always been a place where the unknown waits patiently for us to notice.